We've learned the different patterns of electron flow: nucleophilic attack, loss of a leaving group, proton transfer, and carbocation rearrangement. What we're going to do now is combine these for a reaction. And this leads us to seeing and understanding reaction mechanisms. Let's take a look at a simple reaction the way you might have been presented it in general chemistry. Here we have C8H16O reacting with HBr, leading to C8H15Br plus water. And this was really all you were given and basically kind of expected to think, well, this must be some sort of magic that's happening. But that's not the case. So what we want to do is now represent reactions like this in terms of structures and look at the individual steps that leads us from the starting material to the product. So first you have to know what starting material this molecular formula actually represents. So in this case, it's representing this alcohol. And that's reacting with the HBr. Now, I don't want you to think that at this point you're expected to know exactly what's going to happen here to take us to some product. This is something we're going to work on functional group by functional group, is predicting and understanding reactions. Right now, I just want you to get a feel for the different steps and the patterns of electron flow involved. So in the first step, we have the lone pair on the oxygen reacting with the proton and HBr. We know that this is a proton transfer. And then we'll draw the product of this, where we have 2 hydrogen on the oxygen and a positive charge, and Br minus. And that has the charge there. Next, this OH2 plus that's attached really wants to fall off of the molecule and just be neutral water. So our next step here we know is loss of a leaving group. And when that leaving group leaves, we end up with the carbocation plus water. Now that you have the carbocation, anytime you see a carbocation intermediate, you want to immediately think about the possibility of rearrangement. And in this case, we have a secondary carbocation, but if you do a methyl shift, that secondary cation can become a tertiary cation. So this is the carbocation rearrangement. If you do want to abbreviate that it is a methyl shift, we can do that just by a squiggly line and a CH3. So what that gives us is this intermediate. Next, remember that all of this is happening in a reaction flask. So in this first step, we lost Br minus from this proton transfer, and you have Br minus floating around. That is going to be a nucleophile. This carbocation is an electrophile. So what will happen is the Br minus will come around and add there. And we know that this is called a nucleophilic attack. And we get our final product, which is the C8H15Br. And then the water was lost over here in this step. So what should you know at this point? I don't expect you to be able to take 2 starting materials and immediately go through all the steps and figure out what product you're getting. The things that you want to be able to do is, say you were given an isolated reaction like this, you want to be able to tell me what the pattern of electron flow is. The second thing you want to be able to do, let's say I gave you two pieces with curved arrows drawn in. You want to be able to track those curved arrows and draw the resulting products. The third thing you should be able to do right now is say you're given a couple of starting materials and the product after one step. You want to be able to draw in the curved arrows to show how you get from here to here. So we're going to be working on combining these patterns into reaction mechanisms as the semester progresses. In terms of labeling these things, because it's going to be important when we do energy diagrams, here we have starting materials. At the end, we have a product, and we also generated water as a product. And then from each step of the reaction, we have intermediates. Intermediates are temporary structures that show up on the pathway from starting material to product. So here's intermediate 1, this carbocation, intermediate 2, this carbocation, intermediate 3, and then finally the product.